We're going to need to learn now how to conserve matter in a reaction. So before we talk about the law of conservation of matter again, I just want to remind you that chemical equations represent the type and the number of the changes that occur in bonding. So it's going to show you what happens to each of the elements in the course of a reaction, or the changes that occur in bonding in the course of a reaction. So a reminder of the law of conservation of matter. Matter cannot be created or destroyed. So in the course of your reaction, you can't have any atoms created, you can't have any atoms destroyed. So just some quick reminders of the different vocab words that we're going to be using. On the left side of the reaction arrow, so this is supposed to represent the reaction arrow in a reaction, we call those things that are on the left side the reactants. And the stuff on the right side we call the products. So those are all reminders. Okay, so we're going to try to write a chemical equation to show how you make water. The two elements that we need in order to make water are hydrogen and oxygen. So to start with, we're going to have hydrogen, which if you recall is a diatomic molecule, so it's going to have a 2 on it. And we also will need oxygen in order to create water, which is also a diatomic. And in the process of whatever this reaction is, we're going to create water. As you can see, we have hydrogen and we have oxygen, and we're making the formula for water. But I can see there's a problem already. On this side of my reaction, I have 2 atoms of hydrogen, and on this side, I have 2 atoms of hydrogen. On the reactant side, I also have 2 atoms of oxygen, but on the product side, I only have 1. This looks like has happened is that we have actually destroyed an atom of oxygen, and you can't do that. So in a chemical reaction, we have to be sure that we are conserving matter. So in order to do that, we do something called balancing. So down here where it says chemical reactions must be, we're going to say they must be balanced. And to do that, we're going to make sure we have the same number of atoms of everything on both sides of the reaction arrow. So to balance them, we need to have the same number of atoms on both sides. So how are we going to make that happen? It's not like we can change the formula for oxygen. It has to be diatomic. So the way that we're going to make that happen is we're actually going to use coefficients. And you may have noticed them in reactions you've seen in the past. So we're going to use those coefficients that go in front of the formulas of each of the different atoms or compounds in our formula. So let's go back up to our formula here, and typically what I do is underneath the reaction arrow, I'm going to list all the elements in my reaction. This one's pretty simple. There's only hydrogen or oxygen. And then on either side of the element symbol, I put a line, and that's going to help me because I'm going to keep track of how many atoms of hydrogen are on the reactant side here and the product side here. And then how many atoms of oxygen on the reactant side there and the product side here. Let's go ahead and count them up. On the reactant side, because of the subscript of 2 on the hydrogen, we have 2 atoms of hydrogen. And then on the product side, we also have 2 atoms of hydrogen. So that's good. Those are balanced. Then when we look at oxygen, we have 2 atoms of oxygen on the reactant side. But on the product side, since there's no subscript here, it's really a 1, we only have 1 atom of oxygen. So in order to fix that, we're actually going to insert coefficients in front of the formulas. And we usually start with where the deficiency is. So right now we don't have enough oxygen, and all I can do is put a coefficient in front of water to change that. So now by trying a 2 here, so now there's 2 atoms of oxygen, and that becomes a 2. But I don't have just 2 atoms of hydrogen anymore, because when I distribute this through, I actually have 4. So now that I've fixed my oxygen, my hydrogen's messed up. We're going to start on the side where we're deficient, or we have less atoms, and we're going to see if we can fix that. Hydrogen is 4 on the product side. We want to make it 4 on the reactant side. Using coefficients, if I put a 2 out front here, now when I distribute that through, I now have 4. And now checking this, I'm balanced for each of my elements. Yay, we're done. We don't write in a coefficient on oxygen, typically in a reaction, but a lot of times when they ask this question on the Regents exam, they say after you've balanced using the lowest whole number coefficients, what is the sum of the coefficients? So if you were to add up all the coefficients here, you would actually get 5, because even though it's not written there, there's actually a 1 here. So a lot of times I'll tell my students to go ahead and fill that in just in case they ask that question. The hard part about balancing an equation is not adding up the numbers. They only ask that because they're mean. There's no reason for you to have to add up the coefficients of the elements, or in this case, 2 elements in compound in a reaction. So I would always fill that in. In fact, most of the time, as we move down here, you're going to see a blank in front of each of them, and that's going to sort of help you figure it out. So let's go ahead and try balancing this next one. Again, I'm going to list all of my elements underneath, and I just did that in the order that I saw them on the reactant side. It doesn't matter the order you write them at all. So now we just need to count them. Calcium, we have 1 atom on the reactant side, and way over on the product side, just 1. Carbon, I have 2 on the reactants, 2 on the products. Everything's looking pretty good here. I have 2 hydrogens on the reactant side. On the product side, this is going to get a little complicated. I do have 2 here, but over here this 2 distributes through, so I have 2 more over here, so I have 4 hydrogens on the product side. And then for oxygen, reactant side is 1. And then once again, because this is being distributed through, I actually have 2 atoms of oxygen on the product side. So the only place where we're really having a problem here is with H and O, which you're going to find here in water. Maybe by just messing with this, we can fix everything else. So you'll see that on the product side we have 4 and 2, but on this side we have 2 and 1. So let's try doubling it in front of the water. So now when I put that 2 there, distributing that through, I now have 4 atoms of the hydrogen, and then I now have 2 atoms of oxygen, and it's balanced. But just in case, ask the sum of the coefficients, you want to write in those 1s. And now our sum is actually 5. If you're feeling like maybe you have a good handle on what's happening here, you can probably just pause this and try each of these and then go ahead and check to see if you're correct. And if you're not, then you may want to listen to the entire explanation of each of these. So that's up to you. I'll let you decide how you want to do this. All right, so first I'm listing each of my elements, and I'm going to put a little line to keep my tally on. And now I'm just counting them up. So I have 1 K here and 1 there. 1 and 1. And then my chlorine, I have 1 here and 1 here. 1 and 1. And then oxygen is, of course, a little more difficult. Here I have 3, and here I have 2. Okay, so the only thing that's off is oxygen, and it appears to be deficient on the product side. We're going to start there. What you want to keep in mind when you use the coefficients is you've got to make them both the same at some point. So because the subscript on oxygen over here is a 3, I maybe don't want to double this. If I double this, I'm going to end up with 4, but I can never make this 4 because that's a subscript of 3. So I'm going to use a multiple of these two numbers, which would be 6. So I can put a 3 out front here, making this 6, and then a 2 out front here, making this 6. But that's not the only thing I've changed by putting this coefficient in there. I've also changed the potassium and I've changed the chlorine. So now I got to change those here. Now I have 2 of each of those. So now this side is deficient in potassium and chlorine. And if I just put a 2 here, I've now changed those each to 2 and I'm balanced. Sometimes when you find you end up putting in a coefficient for everything, you'll see that maybe you've gone past your lowest whole number coefficient, and each of the coefficients you've ended up with will have a common factor you can pull out. In this case, I don't have that because it's 2, 2, and 3. Those numbers don't have any common factors besides 1. Next one. I have hydrogen, I have oxygen in a couple places, and I have phosphorus. So go ahead and draw your tally lines. So now we have here hydrogen, which we have 2. Over here we have 3. 2 and 3. And then oxygen, and I see it in a couple places on the reactant side. There's 1 here, and then 10 more right there. That's a big number. That's 11 oxygens. And then on the product side, we have a subscript of 4, so it's 4. And then here on the reactant side again, phosphorus, we have 4 of those. But on the product side, we have just 1. We got a lot of different things going on here. A lot of times when you don't have anything matching up, it's kind of hard to decide where you want to start. I'm going to start with phosphorus just because the phosphorus doesn't have a subscript on the right, so I know that I can use a 4 in front of this, and that's at least going to fix my phosphorus. So I'm going to fix my phosphorus. Now it messed up a bunch of things, but none of them were good. So my hydrogen now I have 12, and my oxygen I have 16. So 12, 16, and 4. So we're still pretty far off. So let's see if we can work out anything else. Now, oxygen's found in a couple of places on the reactant side. And it looks like now with our new numbers, we're off with hydrogen and oxygen. Now, without trying to deal with the oxygen, because it is in 2 places, I'm going to try to just deal with hydrogen, and I'm going to hope that my oxygen falls into place. So in order to make my hydrogens 12 on the reactant side, I'm going to put a 6 out front of the water. And now this is 12. And now I've also changed my oxygen because now I have 6 oxygens here plus this, and that's giving me 16. And sure enough, just by doing that, I fixed my oxygen. Sometimes if you leave alone the one that you have in multiple compounds, it'll fall into place when you balance the rest. So once again, put in the 1 just in case. All right, so let's go ahead and list all the elements in the next one. Again, I'm seeing oxygen in multiple places on the reactant side, but we'll make it work. Go ahead and count up what we've got. I have 1 magnesium, 1 magnesium. Oxygen I have in both the magnesium oxide and water to total 2 on my reactant side. And then on the product side, this 2 is distributed through. So there's actually 2 oxygens on the product side. Hydrogen on the reactant side in the water, there's a subscript of 2. There's 2 hydrogens there. And once again, because this 2 distributes through, I have 2 hydrogens. Hey, wait a minute, look. They all balanced. So we're actually done, but we want to fill these in just in case they ask for the sum of the lowest whole number coefficients. All right, one more. Now this one I like because I can show you how you can deal with some polyatomic ions. So I'm going to start listing these. If you didn't do it this way and you're checking your answers now, don't worry if you didn't list them the same way that I did. I can actually see I have OH on this side, and on the other side I have OHs as well, and it doesn't look as though the O or the H have been split up. I mean, in a sense, OHs have been split up, but the O and the H haven't been split from each other. So on both sides of my reaction, my OH has stayed a polyatomic ion. So I'm going to actually list OH as one thing. You don't have to do it this way, but it might make it easier. And then I have cadmium. All right. So now to go about counting, I have 1 and 1. And then here's the OH deal. So there's 3 OHs here, but on the product side we have 2 here and 2 here for a total of 4 on the product side. So we have 3 and 4 and then 1 and 1. So really the only thing that's off are the OHs, but the problem is, once again, we have a subscript that is odd, which we can't ever have an odd number on the product side because the subscripts are 2. So I'm going to try doubling my NiOH3 in the hopes that by making it even, we can fix this. So now I don't have 3 OHs, I have 6. And it also changed my nickel. I now have 2. So now our nickel and our oxygen are actually deficient on the product side. So I want to fix that. I'm going to try doubling it because I know that'll fix my nickel. And then counting up all our OHs, 2 times 2, here we have 4, plus the 2 from over here gives us 6. And that fixed that. And then you just fill in ones here in case they ask the lowest whole number coefficient, and then the sum of those. So that would be 6. And that's all there is to it.